question here is asking us to find the magnitude and angle of the resultant force. Again, we're looking at these questions, look at all of the information being given, three different forces acting on the same point. Therefore, we are going to interpret all of this information being given to us down here mathematically. So first thing you should do is write down or interpret down all of these informations. So the first thing you say, what is being given? What's given to you in the question? So of course we have F1 equal to 800 Newton. F2 equal to 600 Newton, and finally F3 equal to 650 Newton. These are the three forces being given to you in the question. Looking at their directions, the directions for them, for the F1 here being given is 60 theta equal to 60 degrees from the positive x-axis. For the F2, theta equal 45 degrees, again from the negative x-axis. For F3, we've been given that special triangle 5, 12, 13. So our special triangle here 5, 12, 13. Now since we got all of this information being given to us in the questions down, is written down here, then we need to also specify what is unknown. What is unknown in this case, or what is needed? What is needed is the resultant force Fr is needed, and also phi. Phi is the directions of the resultant force, also is needed. So in your solution, first step as always is you constructing your free body diagram. In your free body diagram, you are going to resolve all of the forces acting on the point into rectangular components as follows. That's your x and y axis. So for the first forces being given to us here, force F1, we know F1, resolving it into two rectangular components, that's F1, which is 800 Newton. For F2 again, resolving into two rectangular components, F2 is 600 Newton. Finally F3, in this case it's 650 Newton, and you don't need to resolve into two rectangular components because it is being given a special triangle 5, 12, 13. This is pretty much all of the information in there. I always like to number all of my thetas inside in there. So theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, and theta 7. Whether I need them or not, I like to always number all of them. So now coming here for the solving for the fx, f1 on the x direction. So for the f1 on the x directions, that I'm going to say, so that will be cos theta 1 equal adjacent over hypotenuse, which is the f1 on the x direction divided by f1. So solving for f1 on the x directions should equal to f1 times cos theta 1. So this one here, just plug in the values. F1 is being given 800 Newton. Cos theta 1 is being given here 60 degrees. this one here should result in 400 Newton. That all should equal to 400 Newton. So for F1 on the y directions, we are going to say sine theta 1 equal to F1 in the y direction divided by F1. Solving for F1 on the y direction, that should equal to F1 sine theta 1, which equal to 800 times sine 60 degrees. All of that should equal to 692.8. That's 692, if I'm not wrong, 0.8 Newton. Now working for F2 on the x directions, again working for cos theta 3 is equal to theta 4 equal to 45 degrees, so either one of them. I'll take theta 4 in this case, which equal negative F2 on the x-axis divided by F2. Why is it negative F2? Because the x component for the force in here, it's on the negative x-axis. So now just solving for F2 on the x-axis equal to F2 times cos theta 4, that equal to F2 is 600 Newton, cos theta 4 is 45 degrees. All of that should equal to again you just plug that into your calculator, and that should equal to negative 424 Newton. Remember that is negative because when you solve for negative F2 on the x directions, for F2 on the y directions, that will be sine theta 4 equal to F2 on the y direction divided by F2. Solving for F2 on the y directions, that will be F2 sine theta 4. The F2 is 600 Newtons, sine 45 degrees. That all should equal to 424 Newton. Sorry, that's 424 Newton. For F3, solving now for F3 on the x direction, that remember that the corresponding sides to the x direction, it is 12. Therefore for this one here, so F3 on the x direction should equal to F3 itself, which is 650 Newton, F3 times the corresponding sides to the x-axis is 12 over 13. When you plug in these numbers in your calculator, they all should equal to that's F3 on the x directions, that is 600 Newton. Then solving for F3 on the y directions, again F3 on the y directions, that equal 650 Newton. Remember that times this times here, since it's y on the negative direction, then negative 5 over 13, that should be negative 250 Newton. Now we got all of the forces down on the x and y directions. F1 on the x direction and y direction, F2 on x and y directions, F3 on x and y directions. By the way, you can express them, guys, into Cartesian forms if you want, but for this case I'm going to continue to solve it to the end. Now I can easily get the resultant forces, but before that I need to sum all of the forces, the forces on x directions equal to F1 on the x direction plus F2 on the x direction plus f3 on the x direction. All of that, plug in these values in there. F1 on the x directions, it's 400 Newton, plus F2 on the x directions, negative 424 Newton, plus F3 on the x directions is 600 Newton. When you plug all of these values, they should equal to 576 Newton. Again, get some of the forces, all of the forces in the y directions equal to F1 on the y directions plus F2 on the y direction plus F3 on the y directions. That all should equal to F1 on the y direction is 692.8 Newton plus F2 on the y direction is equal to 424 Newton plus finally F3 on the y directions, which is negative 250 Newton. All of that again should equal to 866 Newtons. Now we got the sum of the forces on the x direction and sum of the forces in the y direction. Easily we'll be applying Pythagorean theorem to find the magnitude of the resultant force, where we take the square root of sum of the forces on the x directions in here, which is 576 squared, times sum of the forces here on the y directions, 866 Newton, also squared. When you take the square root of these numbers here, they all should equal to 140 Newton. We got the magnitude right now of the resultant force. Now deciding the directions or finding phi for the FR for the resultant force, which is equal to the inverse of tan of the absolute values between the y, which is y here, it's in this case 800, sum of the forces on the y-axis 866 divided by 576, and when you plug all of these in to your calculator, should equal to 56.4 degrees. Now simply just represent that on its positive x and y, represent it on the x and y axis. That's your x and y axis, and it is 56.4. Therefore you're gonna go, that is your resultant force, that is 56.4 degrees from the x axis.